from Germany to Switzerland, now to France, and I'm very happy to introduce Didier Rousseau from Kelenn Technology, driving value through innovation. Inkjet Flexo upgrade, digital watermarking, inline inkjet. Over to you, Didier, and welcome to FuturePrint. Thanks for being a part of it. Thank you very much.
Good morning to everybody. So today I'm going to talk to you about innovation for growth, and we're going to discuss that through applications. But first of all, I'd like to introduce quickly the company and what we are doing, because we are delivering technology in various areas. As you can see here, we are developing vision systems for calibrations and also for, how shall I say, integrity controls during the productions. A lot of printed electronics devices, so that means printing. This is inkjet, but and some other additive technologies to print functional materials, and by the end of the day, print on flex substrates, IoTs, for example, or smart cards, to be more specific. And this is done through 2.5D printing, but we also have developed now fully 3D structured printed electronics machines where we can print from all directions, in all directions, and we also, of course, pick and place chips on the substrates which are printed. Another activity from Kelenn Technology is direct-to-shape printing, where we print on structured surfaces, so any 3D surfaces with photographic quality. The last thing which is related on specialty activities is robotics. Of course, robotics is necessary for direct-to-shape printing or for 3D electronics printing. And these activities are about 35 to 40% of our business, and 60% of the business is inkjet printing, where we are developing the electronics, software, fluid controls. These can be delivered to the customers as well as the print engines and the printers. But now, if we are moving to applications that can be helpful for growth in the packaging business, I'd like to introduce, first of all, the Flexo upgrades that are on the market. As you know, inkjet is very small in business share. In the packaging area, it's about 8%. So the rest of it is analog, and Flexo is the main business for packaging, I would say. There are barriers for adoption. The first barrier, I think, is the print quality of inkjet. The fact that there can be some missing jets, or that the solids are not exactly what customers are expecting, or the gamuts of the colors. And the other barrier is a simple one. It's just the adoption cycle, which is long for any new technology. If now we look at the key factors to change that, I think the first one is the personalization and GS1 code. We've been already talking about that during this conference, and we know that brings mixed marketing, and it's a real incentive for digital. The other key to changes is inkjet performance. Now it's possible to improve the print quality to the level we are expecting, and through a different type of workflow, we can reduce drastically the downtime and increase the capabilities of the digital activities. So these are the key changes. Now, if we look at what we are offering in this area, this is an example of a CMYK print engine that is customizable for Flexos. The key information, I think, is the overall equipment effectiveness that can be achieved with such printers, 95% OE. Now, why this print engine can replace Flexo printing. First of all, because of the DPI resolution full color, 1200 DPI, but also the capability to print solids and color gradients properly, like a Flexo. And for that, then there are some clues, I would say. And the other key factor is the ink, UV ink, compatible to all sorts of applications. Just to give you an idea, within these printers, we print with an ink which can be used for in-mold without varnish. With the same ink, we would print also. Yeah, that's back. We can print on paper. I thought maybe I said something which is wrong, but no. We can print as well on paper. So here is an example. Ink cups, printing on the Flexo machines, or typically with UV ink, or typically water-based ink for some other applications on PET. So water-based ink now is available on these printers, water-based ink to print on PET. As you know, it's new technologies. It's still limited to some applications due to the fact that the ink needs to have a good adhesion on the substrate, and in some cases we need to laminate on top of it, and of course we would like to never laminate on top of the printing. Now, one of the key features for being able to deliver such printers are the system, the mix between the vision system and the printer, the integration of vision system at the back end of the printers with the loop back to the flow system, specifically, typically for correcting missing jet, for equalization of delta E, for automated stitching. This requires only a few seconds of setup at the beginning of a job, and the system is ready for full production, full quality. And because the vision system is there, we will use it as well for integrity check during the production. So with such systems, we can achieve high quality, very down setup time, and full readiness, I would say, for 4.0 factory. Another key application in our viewpoint for innovation and growth is watermarks. So what are watermarks? Well, you can find watermarks on banknotes. They are seen through illumination or straight away, and they are produced actually through a cylinder which is pressing wet paper. And the innovation here is that we can now print that in inkjet. So as a case study here, we can print, for example, a certificate. This certificate will be matching a watermark which is printed on the certificate. You can see this watermark here for direct lighting. Now, with a rear light, it is illuminated. You can see it more. And if the light is UV, then it is flashing UV. Thanks to the digital capabilities, we can vary the intensity of the watermark and create exactly the benefits that the customer is looking for, whether this is in reflectance, transparency, and of course, fluorescence. This is real stuff. This is a machine for printing that. So it's a very compact machine. This is a sheet-to-sheet machine, but we have the same roll-to-roll. And I would like to give you an example of benefits of such security feature for packaging. If we take the example of medicines in Europe and USA, 41 billion of counterfeits are sold every year. How can we counter this situation? I think this is through the end user. So if the end user can easily identify that there is a risk of counterfeit, this will drastically reduce the amount of counterfeit. And packaging is one of the best way, because this is the first level of interaction with customers, to help this business. Watermarks are secure because they are produced only by one company, my company, KT. We have variable images and data which are merged together. There is serialization with GS1 code, so it's fully integrated into the infrastructure now of digital world. And of course, there is fluorescence, which adds security into the process. How can you use that? You can use that directly on the package, up to 250 GSM, as well as simply into a sheet. So you can print straight away onto a cut sheet, which is inserted into the package with the good. And this cut sheet includes the watermark. It's easy for the end user, again, to control that this is a genuine product. There is advanced authentication, which is possible as well, in addition to the one from the end user. And it's very, very cost effective, which is necessary when we think of the amount of products which are counterfeit. I'd like to talk about another packaging innovation. This is about flex packaging. Flex packaging can be addressed in a different way. We can now print straight away at the input of, how shall I say, the finishing activities of packaging. In this case, it's a little bit, it's usually very challenging in terms of cost efficiency. And I'd like to take this example, pouch packaging machines, pouch inserters. These machines are quite difficult to interface because of the movements inside the packaging machine. So here we are printing, so it's a regular system, but as you can see, the pouch packaging is pulling the web, and the interaction here is fully automated and very simple, straightforward, and allows for printing directly in front of the pouch machine. What are the achievements of such a system? Oops. First of all, maximizing throughput. So, because there is non-stop activity with the pouch inserter, and because you are changing the roll, maybe only once every day or 2 days, the rolls are very big, 1.2 meter for a pouch inserter, that's a lot of production which is capable. And what we are doing there is we are capable of almost multiply by 1.4 the throughput of the machine. So for a standard pouch inserter with a printer in front of it, not only there is no latency, but the most important is that the production is growing by almost 100%, multiplied almost by 2. So that's what is interesting into the cost effectiveness of the production. As you know, the pouch inserter is the bottleneck of the production, usually. And of course, the digitization, whether this is monochrome or color, is one of the key features. We've been discussing that a lot during the conference, eliminating labels for lower cost and better footprint, but also all the simplification of the supply chain for the manufacturer, and the reduced setup time, which is just a few seconds. This is a similar technology as the one for the Flexo that we're using here. And of course, late personalization is now addressable with these systems. If I can summarize how applications can produce growth in innovation. Remember, flexo upgrades, inkjet process for digital marking, watermark, and inkjet printing in line with pouch inserters. These are 3 examples of growth in this business. Small applications, but still growth in this business with these applications. Thank you very much.